Okay, so quick recap, then gamma radiation, and we're on our home stretch. So, alpha decay, that's when a nucleus that has too many nuclei emits two protons and two neutrons and turns into a completely different daughter nucleus. The daughter nucleus says, I'm missing something. Similarly, a beta decay is when a parent nucleus loses an electron that changes one neutron into one proton, and it says, I'm a changed man. Notice that the parent and daughter still transmutate, so they are different elements than each other. But gamma decay is different. Remember, gamma decay is where I have an unstable nucleus. It lets out a photon of light, just regular but very high energy light, so it's still the same, it's just rearranged. A gamma ray is a high energy ray of light. Think of the rays of light that you're used to seeing with visible light. A gamma ray has significantly more energy. So, this is emitted when the nucleons are in an unstable position to each other. A gamma particle is massless, so that's 0 for its A number. Neutral, so that's 0 for its charge number. And they randomly interact with matter. A gamma ray can go right through a person, and unless it actually interacts with a particle through something like the photoelectric effect or Compton scattering or pair production, unless it actually interacts with matter, it can just randomly go straight through you without any deposition of energy. In a cloud chamber, you actually don't see the gamma rays in the same way that you can alphas and betas because they don't always interact with matter and can go right through it. You wouldn't see that cloud formation along the path of your gamma ray. So, thinking about an unstable position here, let's say when my magnets are in that unstable pattern position, all the norths are facing up towards me. They go from unstable to stable by releasing energy, and that release of energy is a gamma ray. So our nuclear decay equation is super duper easy because there's no transmutation here. Whatever atom you had before is the same one you have after, but it goes from an excited state, indicated by this asterisk, to a ground state, stable state, by emitting a photon. So pictorially, that might be this unstable looking helium-3. Moves into a more stable position by emitting a photon. And that's it. So keep in mind that this asterisk here indicates the unstable position, and the absence of an asterisk means stable. So if a parent nucleus is simply too big, it has too many nucleons, then it emits an alpha particle made up of two protons and two neutrons, and the parent transmutates into a less massive but more stable daughter. For a beta particle to be emitted, you would need a parent that either has too many neutrons or too many protons. Its daughter would emit a beta positive or beta negative, and the daughter would either have one extra or one fewer proton than before. It would still have transmutation, and the beta particle itself has the mass of an electron and either a positive or negative elementary charge. Finally, a gamma ray has no transmutation. An excited parent, that's this yellowish here, a parent in the excited state, would simply rearrange its protons and neutrons into a more stable state, and that extra energy gets released as a gamma ray. All right, so try the last two problems in this set. Best of luck to you. Happy Monday.